conic sections. Definition. A parabola is the set of points equidistant from a fixed line called the directrix and a fixed point called the focus. The midpoint between the focus and the directrix is the vertex. So a vertical parabola has the equation y equals a x minus h squared plus k, where the vertex is hk and the focus is located c units from the vertex, where c is the absolute value of 1 over 4a. A sideways parabola has the equation x equals a y minus k squared plus h. The vertex is hk. The focus is located c units from the vertex, where c is the absolute value of 1 over 4a. So graph the following. Y equals x squared plus 6x plus 5. To get this in vertex form, I'm going to complete the square. So y equals x squared plus 6x. I'll move the 5 over. To complete the square, I take the coefficient of x, which is 6, divided by 2, 3, and then square it, which is 9. So I add 9. To balance out the equation, I'm going to subtract 9 on the same side. Then if I group these first 3 terms and factor, these will factor into y equals x plus 3 quantity squared, then minus 4. So the vertex is h and k. So the vertex is -3, -4. And then c is the absolute value of 1 over 4a. So 1 over 4 times 1, which is 1 over 4. So this parabola opens upward. So the focus is going to be at -3. And then from -4, I have to move up 1 over 4 since that's c. So -3, comma -3, and 3 over 4. The directrix is c units from the vertex, and the parabola is always open away from the directrix and towards the focus. So the directrix is the equation y equals, I start at the y coordinate of the vertex, which is -4, and I move down c units. So -4 and 1 over 4. The latus rectum is 4 times c. It's the length across within the parabola. So 4 times 1 over 4, which is 1. So the graph of this parabola is -3, -4, which is here, so this point is -3, -4. The focus is right here, so -3, -3 and 3/4. I'll call this F for the focus. And then the directrix is this horizontal line that has the equation y equals -4 and 1 over 4. So the parabola is the set of points where if I take a point here, this distance is the same as this distance. My graph's not drawn to scale, but that is what a parabola is. Let's graph this sideways parabola. X equals 1/2 y squared minus 2y plus 1. So I need to get this in graphing form or vertex form. I'm going to factor out a 1/2 from the terms with a y only. So I get y squared minus 4y, and I'll leave the 1 on the outside. I'll complete the square, so divide the coefficient of y by 2 and then square it. So I add 4 inside, and then I'm going to balance it out by subtracting 2 on the outside. Since this 4 gets multiplied by this 1/2, that's why I got to subtract 2. Those 3 terms inside the parentheses will factor. So x equals 1/2 times the quantity y minus 2 squared minus 1. So the vertex is at -1, 2. H is outside and K is inside. To find the focus, C equals absolute value of 1/4 times A, which is 1/2, which is equal to 1/2. So since this parabola opens to the right, the focus is going to be at -1/2, 2. Since I take the C value and add it to the X value of the vertex, or the X coordinate of the vertex, the directrix is now a vertical line at X equals -1 and 1/2. And then the length of the lattice rectum is 4 times C, or 4 times 1/2, which is 2. So if I graph this parabola, it's going to open to the right. This value here, that's the vertex. That's -1, 2. This point is F, that's the focus. That's at -1/2, 2. To get that point, I take C, which is the distance from here, the vertex, to the focus. This length is C. Then you take C in the opposite direction. The dotted line there would be the directrix. So if I draw a dotted line, the equation of that line is x equals -1 and 1/2, or -3/2. Definition of an ellipse. An ellipse is the set of all points whose sum of distances to two fixed points the two fixed points are called foci is constant. So standard form is x minus h squared divided by a squared plus y minus k squared divided by b squared is equal to 1. Or y minus k squared divided by a squared plus x minus h squared divided by b squared is equal to 1. So for these, a is bigger than b. So on the first one, the horizontal axis is the major axis. So horizontal major axis. And on the other one, the major axis is vertical. So it depends if the bigger number is underneath x or underneath y. The equation to find the foci is c squared is equal to a squared minus b squared. The horizontal axis the length is 2a, and the vertical axis, the length is 2b. On the other one, the length of the horizontal axis is 2b, and the length of the vertical axis is 2a. So graph the following. X squared plus 9y squared plus 8x minus 36y plus 43 is 0. I'm going to group all the x's and group all the y's. If I group all the x's, x squared plus 8x, I'll leave some space to complete the square. With the y's, if I factor out a 9, I have y squared minus 4y, and I'll move the 43 to the right side. If I complete the square on the x's, I have to add 16 on the left side, so I'm going to add 16 on the right side. With the y's, I'm going to add 4, so I have to add 36 on the other side, since 9 times 4 is 36. Then if I factor the first three terms, I get x plus 4 quantities squared plus 9. If I factor these, y minus 2 quantities squared. If I combine like terms on the right side, I get 9. If I divide everything by 9, since I want this equation to equal 1, x plus 4 squared divided by 9 plus y minus 2 squared is equal to 1. So this is in standard form. The center is HK, which is negative 4, 2. Then C squared is A squared minus B squared. So 9 minus 1, which means C is plus or minus root 8. Or C is plus or minus 2 root 2. So since the major axis is horizontal, I'm moving C units from the x-coordinate of the center. So the foci are at negative 4 plus or minus 2 root 2, comma 2. So the center is at negative 4, 2. I'll put a point at negative 4, 2. Underneath x squared is 9, which is 3 squared. So I'm moving 3 to the right and 3 to the left. 3 to the right, 3 to the left. Underneath y is a 1. This is the same as 1 squared. So I'm moving up 1 and down 1. And then if I connect these 4 points, there's the ellipse. The foci are located at negative 4 plus or minus 2 root 2 comma 2. So I'll call this F1. I'll call this one F2. Those are the foci. So if I take a point on this ellipse, the distance from here to here plus the distance from here to here is constant throughout the whole ellipse. If I take a point here, this plus this would be the same as this one plus this one. There is a measure of how wide or narrow the ellipse is, which is called eccentricity. The formula is E equals C over 8. It measures how circular the ellipse is. Definition: hyperbola. A hyperbola is the set of all points whose difference of distances to two fixed points which are called foci is constant. For a horizontal hyperbola, the formula is x minus h squared divided by a squared minus y minus k squared divided by b squared is 1. The vertical hyperbola is y minus k squared divided by a squared minus x minus h squared divided by b squared is equal to 1. The center on both is h and k, the formula to find the foci are c squared equals a squared plus b squared. For the first one, the asymptotes pass through the center with the slope of m equals plus or minus b over a. For the second one, the asymptotes pass through the center with the slope of m equals plus or minus a over b. Graph the following: x squared over 25 minus quantity y minus 2 squared over 4 is equal to 1. So the center is h and k, so 0, 2. C squared is a squared plus b squared. So 25 plus 4. So c is equal to plus or minus square root of 29. Since this hyperbola opens left and right, I'm going to add the value of c to the x coordinate of the center. So the foci are located at plus or minus root 29, comma 2. So if I graph this hyperbola, the center is at 0, 2. So if I put a point at 0, 2, underneath x squared is 25, which is 5 squared. So I move left and right 5 units from the center. 5 to the right and 5 to the left. Underneath y is 4, which is 2 squared. So from the center, I move up 2 and down 2. Then I draw a fundamental rectangle through those 4 points. When I move down 2, it should be at the origin though, not 1 unit below. So then I draw a rectangular box. The rectangular box goes through those 4 points. Then I draw asymptotes that go through the center and the corners of the box. These are the diagonals of the rectangle, through the corners and through the center of the box. Since x is positive, or x is first, this hyperbola will open sideways. So it levels off at the asymptotes, it touches that point, and it goes back out. And same thing on the other side. The foci would be located here and here. So this is root 29, comma 2. The other one is negative root 29, comma 2. The equation of the dotted lines, or the asymptotes, I'll use point slope form. Y minus y1. So y minus the y coordinate of the vertex, or of the center, which is y minus 2, equals the slope of that line. I went up 2 and over 5. So plus or minus 2/5 times x minus the x coordinate of the center, which is 0. You can leave your answer like this. If you get y by itself, it's y equals plus or minus 2/5 x plus 2.